In previous videos, we've discussed the active ingredients and how they work, the attributes that make a formulation suitable for misting, and the label language you'll see on those formulations. In this video, we're going to discuss how the formulations are commonly applied in our equipment. Let's start by getting into just a bit of depth on the topic of dosing. I apologize in advance for the math, but I'm afraid it's necessary for understanding this stuff, and I promise there won't be a test. Recall from the previous video the sentence on the Riptide label that gave instructions for mixing the concentrate to achieve the recommended rate. Mix 1/2 gallon of concentrate in 55 gallons of water to yield a solution of 0.046% pyrethrins and 0.23% properenyl butoxide. Where do the percentages come from? Let's briefly review the arithmetic behind this. Let's start with a drum filled with 55 gallons of fresh water. To make the units work out, let's convert that to US fluid ounces. 55 gallons is equal to 7,040 ounces. Now let's add 1/2 gallon, 64 ounces, of Riptide to the drum and calculate the resulting concentration of pyrethrins in the solution. Remember, Riptide's concentration is 5% pyrethrins and 25% PBO. The remaining 70% are considered to be inerts. We know the pyrethrins are 5% of the 64 ounces, which is a bit more than 3 ounces. We know PBO is 25% of the 64 ounces, which equals 16 ounces. And the inerts are 70% of the 64 ounces, which equal about 45 ounces. To calculate the percentage of active ingredients in the mist, we need to divide by the total volume in the drum. So we start with Riptide, 64 ounces. Then we add the water in the drum, 7,040 ounces. And the total is 7,104 ounces. Now if we divide the 3+ ounces of pyrethrum into the whole volume now in the drum, 7,104 ounces of water plus concentrate, the result is the concentration of pyrethrins in the solution, 0.00046, or 0.046%. You can repeat the calculations for PBO to learn that it is 0.23% in the mist. Now these are very small numbers. To put them in perspective, rather than use percentages, let's use 10,000 as a denominator. When you do this, you see that pyrethrins are only 5 parts out of 10,000. And PBO is only 23 parts out of 10,000, while the water is 9,910 parts out of 10,000. However you look at it, the recommended Riptide dose is very dilute, with only 5 parts out of 10,000 being active insecticide. Make sure you remember that ratio, 0.05%, or 5 parts out of 10,000. In the next video, we'll use that as a starting point in discussing dosing and mist durations to control a variety of insects in different conditions. Now that you understand the arithmetic behind the label, let's talk about how you actually dose up our drum and tankless units by the label. For the drum system, it's very straightforward. You just follow the label directions, putting 1/2 gallon of Riptide into the drum along with 55 gallons of water. We'll provide more detail about the mechanics in the video covering replenishment of a drum unit. In our Gen 3 Plus tankless unit, you have to first make a very straightforward calculation. In the video about the tankless unit, we thoroughly covered the way the unit doses the batch tank. It uses a variable you program into the controller called the mix ratio. The mix ratio describes how much insecticide the machine adds to the water that has been added after a mist in order to achieve the target dose. And it is expressed in parts water to 1 part concentrate. So if the mix ratio is 100, it means there are 100 parts water for every part insecticide. Now let's look again at the dosing recommendation for Riptide. To calculate the mix ratio, make sure the units are consistent. In our case, everything will be in gallons. Simply divide the amount of water, 55 gallons, by the amount of Riptide, 64 ounces, which equals 0.5 gallons. The resulting mix ratio is 110. We'll cover how to program the controller in another video about replenishing the tankless unit. Now let's move to the topic of mist duration and schedule. This is an important topic that is not addressed at all on the insecticide labels, so we'll have to rely on field experience. That is, what seems to work. You might expect the differences in the effectiveness of a given misting program to be driven by a variety of factors like conducive conditions, relative mosquito pressure, or even species. However, in our discussions with our largest dealers bridging dramatically different geographies and climates, a pretty common misting program for an average mosquito problem has emerged. The consensus schedule consists of 2 to 3 scheduled mists per day, a mist of 45 seconds in the hours around dawn, after the sprinkler system is finished, another mist of 45 seconds just after sunset, and an optional third mist cycle between 9 p.m. and 2 a.m., depending upon the mosquito pressure. The homeowner can always make use of an optional remote mist, also with the duration of 45 seconds, just prior to spending time in the area in the early evening. In this schedule, the automated mists are timed to occur when there is unlikely to be human activity on the property. The timing also avoids afternoon winds and daylight activity of bees and butterflies. That's all for this video. In the next video, Days Until Empty, we'll discuss how to calculate how long the insecticide will last in the unit.